Find pencil substring of length k. So for this problem, we are giving a string s and an integer k, and we're going to determine if there exists a substring of length exact k in s that satisfies the following conditions. So the first condition is that the substring consists of only one distinct characters. For example, it can be AAA or BBB, but it must be one distinct characters in this substring. If there is a character immediately before the substring, for example, this is AAA. If there is a character immediately before it, so this character must be different from our unique character A. So this is B. For example, this is AAA. If there's a character immediately after the AAA, so it must be a different character. So which is B. B is different from A. So this is also okay. Yeah. So this means our final result gonna be true, because we can find such cases of this kind of AAA. For this AAA, before it there's no character, but after it, if there is, it must be a different character. Also for this AAA, after that there's no character, but if there is some character before it, it must be a different character. So now let's just try to solve it. But before we solve the problem, we might have some border cases or edge cases. It's going to be really difficult for us to check. But how can we make it easily? It is something called padding. We're going to use padding to make it easier to solve. So we're going to, before it, we're going to just use a hash. It must be a different character from the lowercase English letters, because it is just lowercase English letters only. So we're going to choose another character, and it's going to be different from the string s. So it's going to be hash plus string s plus another hash. We just prepare padding at the beginning and at the end of the character. Now we can solve the problem easily. So for let's just define n going to be from the beginning, let's just define n going to be length of the string, and then we just write a for loop. Normally we're going to write it like n minus k plus 1, but we prepared a padding, and we have to know why we're going to write it like that, because if n minus k plus 1, this means n minus 3 plus 1 n minus 2. This is n and this is for n, and n minus 1, n minus 2 is going to be here, and k equal to 3. This is okay. We have to know such kind of calculation. And now, as we prepare the padding, let's just put 1 here. And at the end, we also prepare padding. Let's minus 1. It means it's going to be n minus k. Now we just need to check, because now we have the padding. It means we can check it directly. It means if there's a character from s, it must not equal to the first character. If there's a character from s, it must not equal to the last character. It means everything going to be valid. We don't need to check the edge cases. So if there's no character, we don't need to check the cases if there's no character before this one, or if there's no character after this one, because that's going to be a little bit hard for us to do. Yeah. Now we just need to check if let's say we're going to use the length of the set with a list of s from I to I plus k. So if it is equal to 1, if it is equal to 1, definitely we need to check if it is valid or not. So here I use a nested if, because I just want to make it easier to understand. Yeah. So if let me just make it easier to write. So this is just from the I. If now I think everything for I is going to be something in between, because this is a hash, and this is some characters, and this is another hash. Now we are just checking all those ones, and all the I are going to be valid, and also including the I plus k. It must be valid. Yeah, so we can check that directly. Yeah, we just need to check if this character should not equal to this character. If the length of the A is here, this character should not equal to the last character. Yeah, we must check such cases. If we can find, we're gonna return true. Otherwise, we're gonna return a false. So in which cases we're gonna return true. This is for if si minus 1 not equal to si and s the last one gonna be si minus plus k minus 1 not equal to si plus k. Yeah, if we meet the conditions, we're gonna return true. Otherwise, we're gonna return a false. Yeah, now as you can see, it works, but it didn't work for the third cases. So the third cases is just a unique character, just one character 8, and the k equal to 1. Yeah, I think it's gonna be a true, because at the beginning and at the end there's no such character. But yeah, let me just check. So for this case here, the n gonna be 1. As we can see, this n gonna be 1. And 1 minus 1 going to be 0. So this means we don't have the opportunity to check such cases, and if we want to check these cases, we have to control it. But this k equal to 1 and n equal to the 1. I think I need to prepare n from here. Yeah, I need to prepare n gonna be length of the new string, and in this case I can check all the possible cases. You see, for this example, n equal to 3, 3 minus 1 gonna be 2, and this one gonna be 1. This means I have the opportunity to check this character, otherwise that is why it is wrong. Yeah, I need to now as you can see it works. So I'm gonna have the opportunity to check this string. Yeah, so here I prepared the length of the string. So normally it's gonna be n minus k plus 1, but there's a hash, so I need to minus 1, so it's going to be n minus k, and that's going to be all the testing cases. I think let me just run it. Now as you can see it works, and this kind of coding is much cleaner. Yeah, we just prepare a padding and everything going to be easier. I think that's all about it. Thanks for watching. See you next time.